Welcome to my algebra class. We are on chapter 5, section 5, and we're going to be multiplying two binomials that results in a special product called the difference of two squares. So when I use FOIL, when multiplying these two, I get a squared first term, outer terms I get plus ab, inner terms I get negative ab, and last terms I get minus b squared. Notice that the middle terms drop out. This will always happen, and you have the result of a squared minus b squared, which we call the difference of two perfect squares. So you're to learn this special product and just go ahead and give the answer. Since the middle terms are going to drop out, all you have are the first terms, n squared, minus the last terms, 4. It's the difference of two perfect squares. Example 2, first terms, r squared, last terms, negative 25. Again, the difference of two perfect squares. Example 3, we get 4x squared. Middle terms will drop out, minus 36. And again, the difference of two perfect squares. And example 4, a squared. Middle terms will drop out. They're exact opposites. Last terms, minus 4b squared. Now you're going to be expected to recognize the difference of two squares and be able to factor it. So if I have a squared minus b squared, I recognize that's the product of these two binomials, a minus b and a plus b. The same binomials except the signs are different. So I see I have the difference of two squares. I put down two parentheses. I take the square root of y squared, which is y, that goes here. And the square root of 864 is 8. 8 times 8 is 64. One of these has to be minus and one has to be plus. It doesn't matter which one you make minus or which one plus. And if you do FOIL, you get the difference of two squares. Y squared minus 8y plus 8y drops out. Negative 8 times positive 8 is 64. Here we have two perfect squares. That's the difference of it, so we'll factor it. The square root of 4 is 2. The square root of x squared is take and divide the exponent by 2. That's x. So we get 2x. Square root of 9 is 3. So one of these is minus and the other one is plus. We have a to the 8th power. That's a perfect square. It's an even exponent. So I divide it by 2 and I get a to the 4th. And the square root of 36 is 6. And one of these is minus and one of these is plus. The only thing I have to watch out for when I do these is to make sure that I don't still have a difference of two perfect squares. This one almost came out that way, however the 6 is not a perfect square, so I had this completely factored. And the last example, a to the 4th minus 25. The square root of a to the 4th, divide 4 by 2, I get a squared. And the square root of 25 is 5. One of these is minus and the other one is plus. And I have copied here the vocabulary if you wish to put that into your notes right now. When you're done with that, we're ready to start the evens to the assignment, so I'll assume that you're done with that. And we're on page 206, written 1 to 18, 27 to 56. Problem number 2. I want you to copy the problem down. Notice that it's the difference. We have two binomials identical except for signs, so we know it's going to come out. The two middle terms are going to drop, so it's y squared minus 49. First terms, last terms. Problem number 4. So the binomials are identical except for signs, so the middle terms will drop out. So it's m squared minus 64. Number 4, I have 9 minus w and 9 plus w. Identical except for signs, the middle terms will drop out. So I have 81 minus w squared. Number 6, 8x minus 11 times 8x plus 11. Again, it'll be the difference of two squares. 8x times 8x is 64x to the second. Negative 11 times positive 11 is negative 121. Remember, you'll always get the difference of two perfect squares, and the middle terms will drop out. Number 8, 7 plus 2a times 7 minus 2a. First terms, 49. Last terms, negative 4a to the second. Problem number 10, I have 4w plus 6z times 4w minus 6z. First terms, it's 16w squared. Last terms, minus 36z squared. Problem number 12, 7p plus 5q times 7p minus 5q. First terms, 49p squared. Last terms, negative 25q squared. 14, 2x plus n to the second times 2x minus n to the second. First terms, 4x squared. Last terms, n squared times n squared is minus n. Add your exponents, n to the fourth. Number 16, 3m squared minus 8n squared times 3m squared plus 8n squared. First terms, 3 times 3 is 9, m squared times m squared, add your exponents, m to the fourth. 8 times 8 minus 64, n to the fourth, adding your exponents. And the last one of this set of problems, xy plus 3z times xy minus 3z. First terms, x times x is x squared, y times y is y squared. Minus 3 times 3 is 9, z to the second. The next set of problems, 27 through 50, well, 27 through 38, you have to factor. So number 28, we're given m squared minus 25. I see that m squared is a perfect square because the exponent's even, and 25 is a perfect square, and it's the difference. So I'm going to factor it to the two binomials. M squared, the square root of that, divide the 2 by 2, and I get m to the first power, and the square root of 25 is 5. So one is plus and one is minus. Number 30, I have 9a squared minus 100. 9's a perfect square, a squared's a perfect square, 100's a perfect square. So, and it's a minus, so we'll break it up into its two factors. 9, square root of it is 3, and a squared, divide the 2 by 2, we get a, so 3a is the square root of 9a squared. Square root of 100 is 10, so one of them is plus, and one of them is minus. 32, we have 16x squared minus 9. 16 and x squared are perfect squares, 9 is a perfect square, and it's the difference. Square root of 16 is 4, divide the exponent 2 by 2, so it's 4x. Square root of 9 is 3. One of these is plus, one of these is minus. 34, I have 81n squared minus 121. 81 is a perfect square, 121 is a perfect square, and of course this is an even exponent, so we have the difference of two squares. Square root of 81 is 9. Square root of n squared is n, so we have 9n. Square root of 121 is 11. One of them is plus, one is minus. 36, have 144 minus y squared. 144 is a perfect square, the square root of it is 12. Y squared is a perfect square, the square root of it is y. Divide the exponent by 2, so minus y and plus y. 38, I have 64u squared minus 25v squared. Square root of 64 is 8. Of u squared is u. So the first term in both is 8u. Square root of 25 is 5. And the square root of u squared is, excuse me, that's a b. Is a b. So one's minus and one's plus 5b. Problem number 40. We have 625x to the fourth minus 1. 625 is a perfect square. If you need a calculator, just take 625, hit the square root sign, and its square root is 25. So this is 25 x squared, divide the 4 by 2, minus 1, and 25 x squared plus 1. Now we're not done, because I always have to check the one that has the minus in it to see if I still have another difference of two perfect squares, and I do. Just like when you do a factor tree and you have 32 and you get to, let's say you have 32, you get 8 times 4. You don't stop there, you keep factoring until they're prime. Well, 25x squared minus 1 is not prime. I can break that down into square root of 25 is 5. Square root of x squared is x. So 5x minus 1 and 5x plus 1. And then I just bring down like a factor tree the 25x squared plus 1. That cannot be factored. It's not the difference of two squares. So all I have to do is check the only one that has the minus sign, and 5's not a perfect square, so I'm done. 42, I have 81s to the fourth minus 16t to the eighth. The square root of 81 is 9. The square root of s to the fourth is s squared. I'll put the minus 1 first. The square root of 16 is 4. And the square root of t to the eighth is t to the fourth, dividing 8 by 2. So the other factor is 9s squared plus 4t to the fourth. Now again, I look only at the one that has the minus sign, and looking at it I can see 9s squared is a perfect square and 4t to the fourth is a perfect square, so I break it down. The square root of 9 is 3, s squared is s, minus the square root of 4 is 2, the square root of t to the fourth is t squared. And the other member of the pair is 3s plus 2t squared. And I bring down the second factor from the top. And looking at the one that has the minus sign, 3 is not a perfect square, so I'm done. (44), I have m to the 16th minus 1. The square root of m to the 16th, divide the 16 by 2, I get m to the 8th minus 1. The square root of 1 is always 1. And m to the 8th plus 1. Looking at the one that has the minus, 8 is a perfect square. It's even, so I divide it by 2. I get m to the 4th minus 1 and m to the 4th plus 1. And I bring down the m to the 8th plus 1. Again, looking at the one that has the minus, I can see again m to the 4th is a perfect square. So I divide that 4 by 2, I get m to the 2nd minus 1 and m to the 2nd plus 1. And I bring down this one. Remember, all those with the plus signs you cannot factor. And I bring down that one. Now I look at the one that has the minus sign. And again, that's the difference of two perfect squares because the exponent is even and one's a perfect square. So that breaks down to m minus 1 and m plus 1. And I bring down the rest. So we're finally done because if I look at m, the number in front, the exponent's 1, I can't factor it any further. On problems 45 through 46, if we look at 46, we have 2a to the fourth minus 18a squared, and that definitely is not the difference of two perfect squares. 2 is not a perfect square, and neither is 18. But you have to remember the first rule of factoring, and that's pull out your greatest common factor. And in this case, we could take out a 2, and we can take out a squared. So that leaves us a squared minus 9. Once I take that out, I see the difference of two squares, so I bring down the 2a squared, and I break this down to a minus 3 and a plus 3. Square root of a squared is a, and the square root of 9 is 3. And the one that has the minus, the 3 is not a perfect square, so I'm done. 48, I have 50 r to the 8th minus 32 r to the 2nd. Again, I can see they're not perfect squares, so I pull out my greatest common factor. That's always what I should do in the first place. The largest number that goes into both of these is 2, and I can pull out an r squared. So that leaves me 25 to get back to the 50. R to the 6, I'm adding my exponents, just take 2 from 8, minus 16. And I bring down the 2r squared, and I see now that this is the difference of two perfect squares. So I factor these. The square root of 25 is 5. The square root of r to the 6 is r to the 3rd, dividing 6 by 2, minus 4, and 5r cubed plus 4. And I'm done. The one that has the subtraction cannot be factored any further. The 5r cubed is not a perfect square. 50, 27a cubed b minus 12ab. Take out your greatest common factor. I can pull out a 3, and I can take out an a and a b. To get back to the 27, I need a 9, a to the 2nd to get to the a cubed. I already have the b, minus 4. That leaves me the difference of two perfect squares, so I bring down the 3ab as one of my factors, and I factor the difference of two perfect squares. Square root of 9a squared is 3a. The square root of 4 is negative 2 and positive 2. And looking at the one that has the minus, that's all I can do. 52, I have 16x to the 5th, y to the 2nd, minus x, y to the 6th. I can pull out an x, and I can pull out a y squared. And that leaves me 16x to the 4th minus y to the 4th. And that is the difference of two perfect squares, so I bring down the xy squared, and this factors to 4x squared minus y squared, dividing the exponents by 2, and 4x squared plus y squared. Looking at the one that's minus, it's still another difference of two squares, so I'll have to break it down. I bring down the xy squared. This factors to 2x. Square root of 4x squared is 2x. The square root of y squared is y, one of them minus, one plus, and I bring down the last factor from the previous line. Looking at the only one that has a minus in it, 2x is not a perfect square, neither is y, so we're done. (54) and 56 are difference of two squares, but they're a little different here. You have to take what's in parentheses and consider it as a single variable. So I have the difference of two perfect squares. So I factor it. There are two factors. Square root of t squared is t. One of them's minus, one's plus. The quantity t minus 1 times t minus 1, the square root of it is just the quantity t minus 1. So if I work this out and distribute the negative sign, I get t minus t plus 1, and that set of parentheses, which just gives me 1. And here I get 2t minus 1. So 1 times 2t minus 1 is 2t minus 1. And the last one, 56, I have 9 times the quantity a plus 1 squared minus 4 times the quantity a minus 1 squared. I have the difference. This is a perfect square and this is a perfect square. So it's going to break down into two factors. The square root of 9 is 3. The square root of a plus 1 quantity squared is just 1a plus 1. I need a little bit more room here. Minus the square root of 4 is 2. The square root of a minus 1 quantity squared is one of those a minus 1s. And then I have the same factor again, except it's with a plus sign between the two of them. So you have to work out everything in here, distribute to get 3a plus 3 minus 2a plus 2. And here you get 3a plus 3 plus 2a minus 2. So the 3a and the negative minus 2a give you an a, and 3 plus 2 is 5. And the 3a plus 2a makes 5a plus 1. So those are my factors. That concludes the evens. Be sure you check the answers in the back of the book for the odds.